right? This is a review for physical science. As you recall, we've been going over balancing chemical equations. Just as a recap, we do know that there are 118 chemical elements that are on our periodic table. You've all been given a copy of the periodic table. You can find one online, you can find one in your book, and you have all the names of the elements there. We do know that your elements are distinguished by atomic number, they're distinguished by periodic trends, electronegativity, their structure, the column, the family that they're in, the trend that they're in, the period that they're in, and so forth. There's a lot of ways to set them apart, but for the purposes of this, I just need you to remember that every single element has an abbreviation that starts with a capital letter. So for example, you see C, that's pretty common, that's always carbon. If you see Ca, that's calcium. Every single element has its own abbreviation, distinguished only for that particular element. So if you can locate that on your periodic table, you can know which element we are talking about and which ones we are combining. So what you're doing here is you're balancing what is on the left side of my arrow, which is the same thing as an equal sign for this particular problem, and you're balancing the left and the right. It doesn't matter if the left seems larger or the right seems larger. Everything on the left must be balanced with everything that is on the right. I'm going to teach you really quick how to, first of all, look at a problem and not be intimidated because it seems like it's pretty lengthy, or it's so uneven, or it's spread apart, or the elements are split up, or whatever can cross your mind. Some of these, if you begin doing the work, you'll notice that they're actually pretty easy as long as you follow the steps. So the first piece of advice that I can give you once again for this is make sure you rewrite your formula, that you are balancing the equation exactly how it is on your piece of paper or your worksheet. So if you manage to just miswrite or miscopy just one of these letters or one of these numbers, you could be working in circles because you're just not going to find the solution to this. Some of these will not work if you don't copy them correctly. So copy it exactly how it is. So once you've written out your entire equation that you are balancing, you're going to count how much atoms of every single element do I have. So on the left, let's start with C. As you'll notice, I've already written out the letters on each side. That is a great piece of advice. You can write them as a single line all the way through the bottom, or split them like this. I did it like this in order to conserve space and be able to do more than one problem. The reason why I want to do this is so that I can easily compare this side to this side to see if they are balanced out. I'm going to count how much of each I have. So on the left side of my arrow, I look for carbon. I only have 7 carbon atoms. I'm going to write 7. You see how there's hydrogen? It's split with a plus sign in between. Hydrogen, I have 9 plus the one I have over here. So I have a total of 10 hydrogen. Then I'm going to look for nitrogen, which is N. I have 1 right there. Oxygen on my left side, I only have 3 atoms of oxygen. So I have 7, 10, 1, and 3 on my left side. Do the same thing for my right side. What I'm going to do is I'm going to count the atoms once again. You have of carbon, I also have 7 on my right side, right there. Hydrogen, I have 6 plus the 2 over here. 6 plus the 2 gives me 8. Then I'm going to count nitrogen. Notice when I'm using parentheses, just like any math problem, also with science, whatever's on the inside of the parentheses, I'm going to distribute to whatever's on the outside. So I have 1 nitrogen on the inside. I have 3 on the outside. 1 times 3, I have 3 nitrogen atoms on my right side of the equation. Same thing with oxygen. 2 times the 3 outside is 6, plus the 1 on this side is 7. 2 times 3 is 6, plus the 1 is 7. So as you'll notice, these are kind of random numbers. The only ones that are currently balanced out is your carbon. Seems a little bit intimidating just because the numbers are so far apart. The equation is kind of split up, and sometimes you'll have larger numbers that you get confused. Before you start working in circles, I want you to step back and notice that some of these are easily solved. For example, you'll notice that your carbon, which is a C, is 7 on both sides. So you're going to work in multiples of 7. Always assume that you can start with just 7 itself. This is what we're going to do for this particular problem. So if I'm gonna start with C7 on that side and C7 on this side, I can go ahead and place 1 and 1 for now. So I'm gonna do 1 for this, 1 for that. Remember, when I place numbers here in these blanks, it affects the entire molecule, which means that if this were to be multiplied here, it would be distributed. Because it's just a 1, nothing changes for my C or for my H. Same thing over there. Remember that you are not changing these numbers next to the elements. That is already a given. What you're changing is what is in the blanks, and that's the only thing that you're allowed to do. Now I want you to step back once again and think, before I start working in circles, what numbers can I place there and how can it affect that? So since we know it won't be a 1, because if I place a 1 here and a 1 there, nothing's really going to change. If we place a 2, we already have a 9 for my H. Placing a 2 here would give me 11 H's. If I want to get 11 H's over there and I automatically have 8, I would need to have 3 over here, because 8 plus 3 is 11. I cannot make this to an 11 because 2 cannot be factored into 11 evenly. Remember, you don't have decimals or fractions in these. They must be whole numbers. So I know it's not going to be 2, because if I make this a 2, it would cause this to be 11, and then that would not work. Once again, I wouldn't place a 2 here for the same reason. The 11 would not be able to be balanced on that side. So let's go with a 3. Let's place a 3. If I put a 3 here, 1 times 9 is 9, plus a 3 gives me 12. Then, if I do this distributed here, because that's what it affects, I now have 3 times 1 is 3. 3 times 3 is 9. With that being said, I'm going to look at my other side. Obviously, my carbon is already balanced. I'm going to look at my H's. I have 12. Remember, I automatically have 6 over here if I were to place just a 1. So in order to make 12, I would also need 6 over here. So 6 times the 1 I already have is 6. If I need 12, that can actually be factored evenly. So let's go ahead and, in order to make this a 6, I need to put a 3 over here. So this is going to change this. 1 times the 6 is 6, plus the 6 is 12. So I'm moving forward because I have 7 and 12, 7 and 12. Remember that I am also factoring this 3 into the rest of it, which means I have 3 O's now, plus the 6 I already have here. 3 plus 6 is 9. So my O's are also balanced. And if you notice, my N's are already balanced as well. So you have 7 and 12, 7 and 12, 3 and 9, 3 and 9. So my answer will be 1 and 3, 1 and 3. My final 2 steps is look for any empty blanks. I don't have any. If there was an empty blank, I would put a 1. And also simplify or reduce. Because there are already 1s in my equation, I cannot simplify or reduce. So if just by stepping back and saying, what number can I place here? How does it affect my other side? You can easily figure out this equation was not that hard once again. Let's look at the second one. Same scenario. Seems like a lengthy one. It seems like there's high numbers. Let me remind you, don't be scared of a number like 12, because you might solve it a lot quicker than you think. So let's count on this side how much atoms I have of each one. So we have C. You do notice there's another C, but that's Cl, that's chlorine. It's separate from carbon. So you only have 5. Then hydrogen, H, you have 8 here, plus the 1 here, plus the 1 here. 8 plus 1 is 9, plus 1 is 10. This might be tricky because of the way it's split. We'll see right now. Then you have your O. You got 2, nowhere else on this side of the arrow, so it's just 2 O's. You got Na, which is sodium. You only have 1 right here on this entire side. We've already, we don't have to do H again. Same thing for this side. Then we got Cl, which is just 1 on this side. So we got 5, 10, 2, 1, and 1. The extra H was in case you wanted to split these separately or use a compound. We don't have hydrochloric acid on that side. We do have sodium and chlorine, but we don't do that separate H again. Let's do it on this side once again. You got 5 C's. H's we have 12. O's you have 2, nothing else. Na you have only 1, and then CO you only have 1. So if you step back once again, you notice you have 5 and 5, 10 and 12, 2 and 2, 1 and 1, 1 and 1. Just by writing out how much of each you have, you realize that this isn't as complicated. The only one that is not already balanced is your H's. Notice how everything else is balanced out. I have 10 on this side, I have 12 on that side. You step back and think, which one do I need to change? First and foremost, you know that 12, there's only a 12 right there and a blank right there. The only thing I can place in this blank is numbers. If you start with 1, nothing changes. If you start with 2, this makes this a 24. You're increasing your number very quickly. You might want to reconsider before you do that, work on this side instead. So what you're going to do is, how about I try to make this side, instead of a 10, a 12. So what you'll do is, I obviously need to increase it by 2, which means that if I'm going to do that, and I already have 8 here, and I want to increase it to 12, I would probably need 4, which means that if I need 4 split amongst these two, what about if we do 1, to not change that, you did 2 right here. 8 plus 2 is 10. What if you did the 2 right here? 1, 2, 2. So we have 8 plus 2 is 10, plus 2 is 12. That obviously changes my numbers over here. You have 2 sodium, then you have 2 chlorine. You'll notice that these are unbalanced. What if you place a 2 here now? This changes my 2 for sodium, 2 for chlorine. You'll step back and you'll notice it's 5 and 5, 12 and 12, 2 and 2, 2 and 2, 2 and 2. Again, you have 5 carbon, you have 8 plus 2 plus 2, hydrogen is 12. You have 2 O's that didn't change. You have 2 sodium, 2 chlorine. Go on that side, you also have 5 carbon, 12 hydrogen, 2 oxygen, 2 sodium, 2 chlorine. My final step, final 2 steps, you have any empty blanks. You do in this instance, you place a 1 right there. Then you simplify. Because of these ones, you cannot simplify anymore. Your answer is 1, 2, 2, 1, 2. Once again, take a simple step of just stepping back and realizing before I work in circles or break my head, what numbers can I easily place there in order to make sure they are balanced. Regardless of how small, how large your problem seems, always follow the procedure. Write out your formula, your equation, exactly how it is on your piece of paper. Write out the elements underneath individually. Remember that capital letters is how you distinguish in your formula every separate element. If you see a lowercase letter, that goes with your uppercase. For example, Na is together, that's sodium. Cl is together, that's chlorine, and so forth. That's the easiest way to distinguish these, and make sure that whatever is on the left balances whatever is on the right. Every number in the blank gets multiplied by every single number of that molecule. Every number in the blank, once again, gets multiplied by every single number in the molecule. If your elements are split, for example, up here, you would add them in between because there is a plus sign. 9 plus the 3 I have here gives me 12 hydrogen on this side. Once again, step back and think, follow the procedure. It sometimes takes for you to almost reach the end of the problem, realize you did one step wrong, you put the wrong number, you multiplied incorrectly, or you planned ahead incorrectly. You're going to have to erase the numbers once again and start over. Very little problems require you to do it multiple times. Most of them will be solved on one attempt, but if that's the case, most of you are probably doing it more than once, and that's okay. It takes practice in order to do this. These are J and K from your first sheet of practice that I gave you, and I gave you plenty of practice. Make sure you're working on that. You'll have another quiz on this again on Wednesday. This upcoming Wednesday, you'll have a second quiz. It's a little bit harder than the first one. You just had a couple more problems, a little bit lengthier, but the same procedure applies. Make sure you practice this. You ask any questions in case you have any. And then starting on Wednesday, we'll practice, or we'll take some more notes actually. Then we'll practice distinguishing the types of reactions that you'll have. You can have synthesis, decomposition, single replacement or single displacement, double displacement, double replacement. You can have combustion, you can have acid-base. We'll learn how to name the types of equations as well, and types of reactions. So please make sure you have any questions, you let me know, and then also that you practice this for the quiz on Wednesday.